The next thing we'll talk about related to matrices is the idea of the transpose. The transpose of a given matrix A is denoted by A to the T, like this right here. And the transpose just switches the rows and the columns of a matrix. As an example, here's the matrix A, and we want to find the transpose. And here's the transpose. The first row of the original matrix is now the first column of A transpose. So I just turned the rows into columns and the columns into rows. Now that we have that, we want to talk about the identity. In real numbers, we know that A times 1 is equal to 1 times A is equal to A. Multiplying by 1 doesn't change anything. And we want an extension of this basic idea in matrices. I want a matrix that I can multiply matrix A by this new matrix and still get matrix A. This idea is known as the identity matrix and is denoted by a capital I. The identity matrix is just a square diagonal matrix with ones on the main diagonal. And as a reminder, diagonal matrix means that everything that's not on that main diagonal has to be a 0. Here's an example of the 3 by 3 identity matrix. We have ones on the main diagonal and zeros everywhere else. Since we're claiming that this works like multiplication by 1, let's try it out and make sure that's accurate. So we start by multiplying the first row by the first column. 1 times 0 is 1, and then 0 and 0 means that entry is 1. The second column, 1 times 2 is 2, and then I have 0 times 3 and 0 times 0. Therefore, I'm just left with 2. When I move to my third column, I have 1 times 1 is 1, 0 times 2 is 0, and 0 times 1 is 0, which just gives me 1. Moving down to my second row in the first matrix, I can do second row, first column to get 0 plus 1 plus 0. My second row, second column would give me 0 plus 3 plus 0. And my third column gives me 0 plus 2 plus 0. I then go down to my third row, first column. That would be 0, 0, and 1. Second column would be 0, 0, and 0. And finally, third row, third column gives me 0, 0, and 1. So this did work exactly the way I wanted it to. I multiplied these two matrices, and I got back to this matrix that I started with. Since we know matrix multiplication is not necessarily commutative, we do need to check both directions. First row times first column would give me 1 plus 0 plus 0. Second column gives me 0 plus 2 plus 0. And third column gives me 0 plus 0 plus 1. Moving down to the second row, first column, I have 1 plus 0 plus 0. Second column gives me 0 plus 3 plus 0. And third column gives me 0 plus 0 plus 2. Third row, first column, gives me 1 plus 0 plus 0. Second column gives me 0 plus 0 plus 0. And finally, third row, third column gives me 0 plus 0 plus 1. So once again, I got this matrix that I wanted.